Automatic, Addison.
In this tutorial, we will focus on lists in Python, a versatile data structure that is especially useful in robotics for handling collections of items like sensor readings or robotic commands. Let's start by opening a terminal window. And let's move to our Python tutorials package. We'll do cd ~documents, Python tutorial. Clear that out and let's open VS Code. You can see VS Code opened here. I'm going to clear things out and declutter it a little bit so it's easier for you to see. And let's start by creating a new file named robotics list.py. So I'm going to go over here, right click, click new file, and we're going to do robotics _lists.py. And let's start by typing a comment here. I'm going to say pound sensor data list. Let's do sensor readings equal open bracket. We're going to do 20, comma, 55, 75, 10. Let's do print initial sensor readings. So I need to use single quotes here to follow the ROS2 Python style guide. Since we don't have any escape character, you'll learn about that in a later tutorial. We use single quotes and we'll do sensor readings and then save. And let's run it just to see where we have, and we can see the list was printed to the terminal window. This list holds some dummy sensor readings. We see 20, 55, 75, and 10. Now let's see how we can access elements from this list. So I'm going to say pound accessing elements. And on this line, we'll do print, open parentheses, we'll do first reading. Oops, didn't spell first right. First reading, colon. And we'll do sensor underscore readings, parentheses 0. And let's do pound 20. And we'll do print most recent reading, colon. Let's do comma here, and we'll do sensor underscore readings, open bracket, -1. Close parentheses, and this should be 10. Let's see what it's screaming about here. It looks like there is a problem. Let's see, is this closed? What's this talking about here? Let me go to the problems piece so we can see it. Statements must be separated by new lines or semicolons. Let's see, where is the issue? Most recent reading. Oh, I have an extra parentheses. Save. Okay, now let's go to the next line. And let's run it. Okay, so first sensor reading is at the 0th index. And the 0th index you could see is 20. And this -1 right here, when you have -1, it gets the last part of the list, the last index in the list, which is 10 is the item at that area. Now suppose the sensor is recalibrated and you need to update its reading. Let's go down here and let's type updating a sensor reading. Sensor readings. We're going to do open bracket. And let's update the reading at index number 2. We're going to do equals 80 here. And we'll do print, open parentheses, updated readings. Let's do comma sensor readings. Okay. And now let's press play. And you can see we updated the 0, 1, 2, the value at index 2 from 75 to 80. And this is the syntax. You do sensor readings, which is the list name, open bracket, the index where you want to update, close that bracket out, and then assign the new value. And in this case, that is 80. And then we printed out the entire list after that. So right now, let's add new sensor data to our list. And you can do that by using the append command. And let's work on that now. I'm going to open up, adding a new sensor reading. And let's do sensor readings dot append. You see the VS Code actually suggested it, append. And I'm going to do open 65. And then down below here, we're going to go to print readings after append. And we're going to do a comma, say sensor readings. Okay, so we appended 65 to our list, and then we are going to print out the new list. Let's see what we get here. Now we have five elements in our list. 0, 1, 2, 3, 4 right here, index 4 is 65. It was appended to the end of our previous list. That's how you use append. If you want to add an item to your list, remember, use the append function. So let's see how we can do the opposite, which is to remove a reading. Let's say in a real world use case, the sensor malfunctions and you might need to remove its data. So let's do hash right here, or pound, if you're American like me, delete sensor. Let's see. No, let's create our comment here. Remove a sensor reading. Okay, and let's do delete sensor readings, open bracket. We want to delete the first reading, for example. So removing the first sensor reading. And then down here, let's do print, open parentheses, readings after deletion, colon, comma, sensor readings. Save. And let's run it. And you can see we removed the first reading. So we went from 20, 55, 80, 10. Now we had appended the 65. So we have 5 elements. And now we're back to 4 elements after we removed the first element by putting the index of the reading that we wanted to remove, combined with the delete operator, D-E-L. So to handle each reading, say for analysis or adjustment, we need to iterate through our list. And let's show how to iterate through sensor readings. Iterate means to go through each one methodically. So we're going to type a hash symbol and we do iterating through sensor readings. So how do we go through this list? We do for reading and sensor readings. That's the beauty of Python, is that it sounds like English and it's quite intuitive. So for the reading and sensor readings, we are going to print that reading. So for each reading and sensor readings list, we're going to print that reading. And let's do processing reading, colon. And then we do comma here and then do reading. Let's run it. And you can see we went through each one methodically. 55, 80, 10, and 65. That's how you go through each piece of the list, each element in the list. That is it for lists. Now let's explore how to create a set in Python. Sets are perfect for managing unique items in robotics, like tracking visited locations or unique sensor IDs. Let's look at that now. I'm going to clear my terminal window. And let's create a new file called robotics sets.py. So robotics underscore sets.py. Enter. Right, and let's type the following. Let's get rid of this list program, and let's type the following into the code editor. So creating a set of unique sensor IDs. Sensor IDs variable equals open curly braces, and let's do 101, comma 102, comma 103, comma 104. So that's how you do the sets right there with the curly braces, and then put whatever values you want in there. Very similar to a list, but you're using curly braces instead. And let's print that out. Print, open parentheses, unique sensor IDs. And do comma sensor IDs. Okay, and let's print. And here we go. We printed out our set right there, unique sensor IDs, and the set right after that. So it's really cool because sets can automatically handle the uniqueness. So let's actually test that out by adding some duplicates, adding a duplicate in here. So we've got 101, 102, 103, 104. What happens if we actually update the set with the value that is already in the set? 102, for example, or 103. Let's add a couple duplicates. So I'm going to do a comment here. I'm going to say attempting to add duplicate sensor IDs. And we'll do sensor IDs dot update. So dot update to add another element to the set. Open parentheses, and we'll add 102, which is already in the set. We'll add 103 and 105. Save. On the next line, let's do print, open parentheses, updated sensor IDs. And we'll do comma, sensor IDs. And let's run our program. And you see that? See that? See how we added 102 to our set? We added 103 to our set. You would think we would have 1, 2, 3, 4, 5, 6, 7 items in the set. But because sets automatically handle uniqueness, unique values, we only have unique values in the final set. So we have 101 through 105. So sets totally ignore duplicates. They will only add unique items when you use that update operator. So let's see how we can add new sensor data and remove outdated ones. To do that, we use the add and discard operators. So let's do managing sensor data, and we'll do sensor IDs dot add open parentheses 106, and we'll do print after adding, and we'll do comma sensor IDs. And then down here, we'll do sensor IDs dot discard. You can see Visual Studio Code automatically suggested that. So adding 106, which is a unique value, and we are going to discard 101. So print after discarding, colon, and then sensor IDs. And let's press play. So you can see here, after adding 106, we added another unique element to our set. We have 101 all the way through 106. And then we subsequently removed, discarded 101. And so we're left here with 102 through 106. Note that the discard operator is safe to use because it won't cause an error if the item doesn't exist, unlike the remove operator. We can also perform set operations like unions and intersections, which is useful for comparing sensor data across different sets. And let's get a look at that right now. Let's go to the next line. I'm going to type set operations with sensor data. We do another underscore set equals open curly braces 104, 105, and 107. And let's save. And down here, I'm going to type print, open parentheses, union. I'm going to type sensor IDs dot union, and open parentheses, another set. And then down here, print, open parentheses, intersection, sensor IDs dot intersection, another set. Save. See what we did here? We did union, and intersection. So we want to calculate the union of this another set with the original sensor IDs, and then the intersection. What elements can be found in both sensor IDs as well as another set? Press play, and here we have the intersection. So 104 and 105 is in both sets. And the union, which is the combination of all those, is 102 through 107. So this is really cool because these operations, both the union and the intersection, help determine overlaps or combining data from multiple sensor sets. You'll observe how sets efficiently manage unique items and perform operations that are important in robotics. So let's clear that out. Next, let's look at how to create a tuple. Let's clear out our terminal window. Let's close this. So what is a tuple? Tuples are immutable collections, meaning once created, you can't change their elements. They are ideal for data that should remain constant and should never change. So let's create a file, right click, click new file. And we're going to call our file using underscore tuples dot py. And let's create our first tuple. And what you should know is that tuples are defined by enclosing elements in parentheses. So let's do that now. Pound creating a tuple. Next line, coordinates equals 10, 20, 30. Save. Then our next line, do print, open parentheses, coordinates, colon, and do comma, coordinates. So this tuple, what would that represent? Say in a robotics use case. Well, maybe it represents coordinates in a 3D space. So let's press play. And here we have our tuple 10, 20, and 30. So tuples are also good for accessing elements by index. So let's work on that now. Pound accessing tuple elements. We do print, open parentheses, x coordinate, colon, and do coordinates, open bracket, and 0. And then down here we do print z coordinate, colon, and let's access the end of it by doing open bracket -1. Remember how to do that from our list section of the tutorial. And we are going to save, and let's press play. and we have an issue. And the issue is I don't know how to spell. So coordinates. Save. Let's clear that out to click the clutter, and we'll press play. Okay, x coordinate 10 and z coordinate 30. So you saw we got 10 and 30. The first element, 0, and the last element, 30. Clear that out. Tuples can also hold mixed data types and can be unpacked into separate variables, which is very handy in many situations. Let's look at an example. Tuple with mixed data types. Unpacking. Next line, info tuple equals open parentheses, and I'm going to say item, comma, 150, 23.99. So you see we've got mixed data types in this tuple. We've got a string here. We've got a, I'll put my cursor here, a string here, an integer, and a floating point value. And let's call it name, quantity, and price, info tuple. Now we're unpacking that tuple into the values name, quantity, and price. And let's print unpacked, colon, and say name, comma, name, quantity, and price. Save. Press play. So you can see we have unpacked it. And so we've unpacked the name, which is the first value here in our tuple, which is item, then 150, the integer, and then 23.99, which is the floating point value. So we saved our file. So you can see how tuples can be used to store and handle data securely and efficiently. Okay, let's clear out our terminal now. Let's close this program. We're going to move to the next topic, which is dictionaries. Let's explore how to create and use dictionaries in Python. Dictionaries are a fundamental data structure for storing key value pairs, which is useful for managing complex information. So let's start, as we always do, by creating a new file to learn about dictionaries. And I'm going to call this file creating a dictionary.py. Creating a dictionary.py. Enter. And here's how to define a dictionary. We're going to use curly braces, and we need to have keys and values. So creating a dictionary, and let's do robot parts equals curly braces. And then our first key is wheels. How many wheels? We have 4, and then we comma to create our next dictionary entry. And I'm going to say motors. How many motors? 2, comma, and then sensors. How many sensors? We have 5 in this robot. Save. And then we're going to print it out. Print, open parentheses, robot parts dictionary. Okay, and then comma, robot parts. Let's print. Okay, and here we go. So we have robot parts dictionary, wheels 4, motors 2, and sensors 5. So this is an example that creates a dictionary to track robot components. Now let's make a more complex dictionary, something a little bit more interesting. So I'm going to say dictionary with various data types. Okay, and I'm going to say here, we're going to say, call it robot specs equals. And to make this easier to see, I'm going to break up the key value pairs on different lines. So we're going to say name, automatic, Addison, robot, comma, parts, robot parts. Next entry, features, open bracket, and I'm going to call this autonomous, comma, solar powered, comma, waterproof. Okay, and then the last one is dimensions. Height. Okay, 120. Width, 75. And weight, 150. Okay. Need our comma there at the end of waterproof. Okay, and now let's go to the next line and let's do print robot specifications dictionary. Okay, let's put a colon there and we're going to do robot specs. Robot specs. Come on. Okay, and then do print to add a blank space there. And let's press play and see what we get. And you can see our robot specifications dictionary with all of our entries, our key value pairs. So let's try to access or modify the dictionary data. And to do that, we need to reference the keys. So the keys are like this right here: name, parts, features, dimensions, and the values are to the right of the colon. So key value pairs. And let's look at how to access and modify dictionary values. So accessing and modifying dictionary values. Print robot height, robot specs, say dimensions. Okay, and we need to go over here and access height. Save. So print robot height and then robot specs, dimensions, and height. And let's add another name, print. Oh. Next line, and we're going to do robot specs, open bracket, and we're going to say speed here. Equals 25 kilometers per hour. See what we did here? So with robot height, we had to access the value by putting dimensions in here, dimensions, which is the first key, and then the other key, which is height over here, which is paired with 20. All right. And then robot specs, we have the speed, which is right here, 25 kilometers per hour. We're adding that. Okay. So in the first one, we're accessing the value. In the second one, we are modifying the value. And let's add some space so it can look nice and pretty in the terminal output. And I'm going to press play here. And I see, you can see here, we print robot height. and we accessed that value of 120 because we had dimensions and then height as the two keys. So dictionary within a dictionary right here. Dictionary on this line within the dictionary. So dimensions, first key, and then the height is the second key, and that gets 120 for the robot height. And we also have robot spec speed. This is our addition right there. And what I left out here was actually printing the updated dictionary. So let's do updated robot specifications, colon, and then comma robot specs. Okay, so now we'll be able to see the updated dictionary with this new key value pair in all its glory. Where is it? Where is it? There it is at the end of our dictionary. Speed 25 kilometers per hour is now added to the dictionary. And let's see how we can remove an item. I'm going to go down here and say removing an item. So delete robot specs, open bracket, and then we're going to say speed. So print after deletion, colon, comma, robot specs. Say print, save. Okay, and let's play that. So after deletion, before deletion, we had speed right here. And then after deletion, we did the delete robot specs, deleted that key value, speed in the dictionary. We get nothing in the final dictionary after deletion, which is exactly what we should get. Now, before we conclude this segment on dictionaries, you should know that dictionaries can be traversed using loops to access all keys, values, or both. So let's see how we can loop through a dictionary. I'm going to type a comment here that says looping through a dictionary, and we'll do for and do key, comma, value in robot specs dot items. The dot items right there. Print the key, comma, going to put a colon there, and then the value, and then save. So that's how you do it. For key and value in robot parts dot items. Print the key, followed by the colon, followed by the value. So now let's run the script. And you can see we printed wheels, motors, and sensors. Wheels, motors, and sensors. Pretty cool. Key value pair right there in the robot parts dictionary. So now we're going to go down here and let's clear this out just so it's easier to see. So you can see how effectively dictionaries can store and manage complex data. So that's a quick guide on creating and using dictionaries in Python. Thanks for following with me, and I will see you in the next tutorial. Keep building.